Hi and Assalamualaikum. My name is Kairina Dawiti Jasri, and today I would like to share with all of you about my final year project entitled Conversion of Mixed Agricultural Waste of Palm Kernel Shell and Palm Oil Front into Porous Activated Carbon via Microwave assisted with Potassium Carbonate Activation. Do you guys ever know that Malaysia is the nation's second oil producer globally? From which then we create various waste from the palm tree itself, such as palm kernel shell and palm oil front. By all means, we are actually have been long supported the investment to the climate change. Typically, palm oil waste is usually be burned to be removed, and it apparently causes a greenhouse effect. As a result, palm kernel shell and palm oil front are introduced as the primary product for producing activated carbon. Just to know that conversion of mixed industrial waste into porous activated carbon can give advantages to the studying the potential of palm kernel shell and palm oil front as a new substrate of activated carbon in absorption of wastewater treatment. In advance, it can reduce the industrial waste generated in Malaysia. Besides, this study can reduce potential hazard and pollution due to the increasing number of waste generated every year. On the other hand, it means Malaysia can minimize waste disposal costs. Moreover, as we use microwave in the carbonization method, it means that we can reduce the volume by 80% and the emission rate is also minimal. Therefore, it helps in reducing energy and time while handling this research. There are 3 objectives that yet to be achieved in this experiment. The first one we have here is to convert the potential of palm kernel shell and palm oil front into activated carbon using microwave assisted by potassium carbonate. The second one is to identify the physical chemical properties of produced activated carbon by using several analytical techniques such as surface area analysis, surface morphology, and also functional group. The third one is to evaluate the absorption performance toward removal of methylene blue from the aqueous environment. Now let's move into the finding. For functional group, it can be seen that raw PKS-POF activated carbon IR spectral has a strong peak at 3,840 until 3,360. It also has a strong peaks at 2,340 cm. It means that there are the presence of alcohol and methylene group. Morphological structure and element composition of PKS and POF activated carbon can be seen, whereas the morphological structure of PKS and POF activated carbon shown that it has uneven surface with a spine-like structure. It has proven that PKS and POF activated carbon are very porous and suitable for adsorption of methylene blue. The occurrence of C, O, and N element in the structure of PKS and POF activated carbon were examined by EDX analysis. The surface of PKS and POF is denser with reduced pores after MB absorption. This can be the reason due to the stacking of the MB dye molecules on its porous surface. After the MB absorption, using EDX analysis, it can be confirmed that there are absorption process happen with the presence of S on the surface of the PKS and POF activated carbon. The S element are actually coming from the molecule structure of MB dye. Next, for XRD analysis, PKS and POF before transformed into activated carbon has cellulosic peak. The XRD pattern of PKS-POF activated carbon reveal characteristic diffraction peak at 25 degrees Celsius. The presence of white XRD spectral line suggests that PKS and POF activated carbon geometry is amorphous. To summarize, palm kernel shell mixed with palm oil front activated carbon was successfully prepared by pyrolysis of sample for 15 minutes in a customized microwave oven with fixed temperature of 800 degrees Celsius in the existence of nitrogen gas. The findings indicate that palm kernel shell and palm oil front industrial waste can be used to obtain large specific surface area activated carbon with highly porous structure and high adsorptive affinity against methylene blue. For suggestion, it is suggested that activated carbon will use another chemical for activator rather than using potassium carbonate. Mixing 2 or more wastes are suggested to be continued as mixed wastes have been more efficient than using just one waste. And hence, that's all from me. Thank you.